Swayam Prabha. Digital India. Educated India.
So, the question what I am asking, why not calculating arithmetic mean, calculating AM arithmetic mean of the salaries from 3 regions instead of estimating dummy variable model. Can you think of why we are not taking arithmetic mean and just compare? Yes, you can always compute arithmetic mean, and comparing the mean you will get to know whether there is any mathematical difference between the mean values, but what you will not know is whether the difference is statistically significant or not. So, in econometric analysis always our objective is to get the statistical difference, not the mathematical one. So, arithmetic mean will only tell you whether there is mathematical difference in the mean values, but this dummy variable model will tell you the statistical significance. So, that means the answer to this question is to get statistical significance, statistical difference in the mean values. That is why dummy variable model. If you go to the output once again, if you compute mean value of the northeast or north central, then that will also apparently show you, yes, the mean value of northeast or north central is also different from that of western region, because that value would be 26,158 minus 1734. But this 1734 difference, is it statistically significant? That the arithmetic mean cannot tell you. That will know just by looking at the significance of the D1 coefficient, and it is not significant. So, even though mathematically it is different, statistically it is not. Okay. Similarly, the D2 coefficient, it is statistically significant as well as mathematically. So, that is the advantage of setting the dummy variable model. Okay. That is the advantage, and that is why we are setting dummy variable model, even though our objective is to examine the statistical difference. Objective is to see the statistical difference in their mean salary. Okay, mean salary. But one more thing that we have to keep in our mind, whatever analysis we did so far, we only know there are differences in mean salary of the other 2 regions compared to the base category, but we do not know what is the reason for that difference. What I am saying? So, the source of difference in mean salary is not known from the ANCOVA model. from the ANCOMA model, because in the right hand side there is no other explanatory variable. So, we do not know what is the reason for these differences. Okay. Now, can you think of what could be the reason why the other regions are earning less salary compared to the western region? One possible reason would be, it might so happen that in western region the state government is spending more, public spending per student is more compared to the other two regions, and when public spending is more, obviously the salary of the teachers from that particular region will also be more. So, public spending is one reason, or it might so happen that the cost of living is also higher in the western region, for which the government is giving extra salary, that is also possible. All right. So, what we have to do, since we have data on the public spending as well, let us see whether there is any significant difference in the mean public spending of these three regions. Like the way we examine the difference in mean salary, in the same way we can examine the difference in mean public spending per student. So, that is also possible. So, how will you do that? The same model, okay, same model, what we have to do, instead of, so that means what we will do here, we will say that spending of the ith state equals to alpha plus beta 1 d1 I plus beta 2 d2 I plus ui. Okay. So, in this model, if you set this type of model, then you will know, depending on the value and say magnitude and the significance of beta 1 and beta 2, how I am defining beta 2, the definition of d1i and d2i is same. So, same way I am defining d1i equals to 1 if northeast or north central, 0 otherwise, d2i equals to 1 if south and 0 otherwise. Okay. So, you will get expectation of spending. So, you will know that, that means expectation of spending given d1i equals to 0, d2i equals to 0. So, that would become alpha, which is the spending for the base category of west. Likewise, you can derive the interpretation of beta 1 and beta 2 in the same way we have derived in the context of mean salary, right. So, what we will do, we will now estimate the model. Okay. So, this is expectation of spending given d1i equals to 1, d2i equals to 0, that is alpha plus beta 1. So, this is for the base category west, this is for the northeast or north central, and if you take expectation of spending when d2i equals to 1 and d1i equals to 0, that would become alpha plus beta 2, which is basically for the southern region or south region. All right. Now, we will estimate. So, same way now we will put spending, then d1, then d2. Okay. Spending d1 and d2, if you you have to put reg command, reg for regression space, you have to give a space, then spending D1 and D2, and then after that you have to put enter. Okay. And same way you can interpret these coefficients. What does the constant term indicate? Constant term 3919 tells you that this is the spending of per student spending in the western region. So, government in western region spends $3,919 per student yearly, and that of northeast or north central is 3,919 minus of 18 point something, and then for the southern region it would be 3,919 minus 644. Okay. So, that means you can say that alpha equals to 3,919, that is the mean spending. That means this is the spending per student in west. Okay, in west. Now look at the coefficient. D1 is not significant, D2 is significant. Of course, it is significant only at 10% level, because if you multiply the p value with 100, that becomes 9.6, which is greater than 5, but less than 10. So, one thing is clear, since in the previous example we saw that there is no significant difference between the mean salary of the northeast and north central with west, you see that there is no significant difference in spending as well. So, when there is no significant difference in spending, obviously you can understand there won't be significant difference in the salary as well, which is true by looking at the results of the spending estimation, spending equation. Okay. Now, in the third case, what we will do? These models, the first model we introduce only in the ANOVA format without introducing any explanatory variable in the right hand side. Let us now introduce the covariate which is spending and modify the model. If you introduce the covariate in the right hand side, that would become an ANCOVA model, and it will look like salary equals to alpha plus beta 1 d1i plus beta 2 d2i plus beta 3 x1i plus ui. Okay. And how we have defined x1, d1i and d2i, their definition is same. So, that means d1i equals to 1 if northeast or north central, 0 otherwise, d2i equals to 1 if south, 0 otherwise, and x1i is actually the spending, public spending. This is per student. Okay. Now, in this example, what we did, we have introduced the dummies, but we have not interacted the dummies with the covariate x1. Okay. What is the assumption behind this type of model? Can you think of? When there is no interaction between the dummy variable and the explanatory variable which is spending here, what does it indicate? What is the implicit assumption? First of all, what would be the interpretation of beta 3? Beta 3, how will you interpret beta 3? Beta 3 is basically, beta 3 indicates the responsiveness of salary with respect to public spending. So, when public spending increases by 1 unit, public spending increases by 1 unit, on an average the salary increases by beta 3 unit. Okay? And since there is no interaction between the dummy variable and the covariate, okay, so no interaction here in this model, there is no interaction, between the dummies with x1I, which is spending, and this basically indicates responsiveness of salary with respect to public spending is same across different regions. What I am saying, responsiveness of salary with respect to public spending is same across regions. Okay, it is same across regions. So, one extra unit of spending results in beta 3 amount of increment in the salary of the primary school teacher, irrespective of whether the teacher is coming from southern region, western region or northeast or north central region. That is the assumption. That is why no interaction between dummy and the covariate indicates this. If you believe no, this is actually not the same, when public spending increases, different states salary responds differently, then you have to interact the dummy with the quantitative variable spending. We are not doing it here for simplicity's sake, but if you believe that, then you have to interact the dummy variable with this. Okay. So, every additional spending results in beta 3 amount of increment in salary for all the regions. Okay, that is the assumption we maintain here. All right. Now, what I will do, I will estimate this third model. Okay, and for your sake, this particular example is an ANCOVA model. So, now we will estimate this ANCOVA model, and what would be the command for this? Simple, reg, then your salary then D1, D2 and spending. This is your complete model, okay, spending, and this is the result. Now, if you compare this result with the earlier one, this result is quite different from the result that we derived earlier. In earlier cases, in the ANOVA model, the intercept value was something around 26,000, but now it is 13,269. That means mean salary of the western region is now 13,269, which is quite different from the earlier models. Why? Obviously, in earlier model was the ANOVA model, because in earlier model there was no quantitative covariate included in the model. Spending was absent. In absence of spending variable, it might so happen that the earlier ANOVA model was misspecified. Okay? So, that is why your claim that all the difference in salary is coming just because the teachers are coming from different regions is quite absurd. So, that is the reason when you include the other covariate spending, your results are changing. So, the D1 variable which was not significant earlier, now it is significant at 5% level. D2 variable which was significant earlier, now it is insignificant. That is the thing. Okay. So, likewise, you can estimate the mean salary of the other two regions by subtracting 1673 and 1144 from the constant term. Okay. But one striking point here is the spending variable is highly significant, and that is positive also, that is positive. So, that means when average spending increases, that results in significant increase in monthly salary, okay, monthly salary, and the estimate of the spending coefficient is 3.28. So, that means every additional unit of spending results in 3.28 unit increment in salary. So, this beta 3 equals to 3.28. Okay. So, every additional spending results in 3.28 unit increment in 3.28 unit increment in salary. Okay. Now, what we will do? We will try to represent this result in a diagram, that will make the things much more clear. So, we will go to the next page, and what we will do now? In x axis we are measuring spending, and in the y axis this is salary, okay, salary. Let us say that, or let me let us say that this is for the West, the base category. So, this is basically alpha, the coefficient, the intercept term, okay, this is alpha. So, intercept indicates the mean salary of the western region, and then you see from the result that D1 is significant, but D2 is not. So, that means salary of the southern region is not significantly different from the western region. So, what I will do? I will put the southern region's value like this is for south, and this is for northeast or north central. Okay. Since all this regression they have same slope and that is beta 3, all these lines are actually parallel. All these lines are parallel, same slope. Okay. So, alpha plus, if you go back, look at, so alpha plus beta 1, alpha plus beta 1 would be, alpha plus beta 1 would be the intercept for northeast or north central, and alpha plus beta 2 would be for intercept for the south. Okay. So, since alpha plus beta 2, that means beta 2 is insignificant, I will say that since beta 2 is insignificant, so that means this is basically alpha plus beta 2. Okay, alpha plus beta 2, and this is alpha plus beta 1, that is significantly lower than that of the western region. Okay. So, all the 3 regions have same slope. So, that means we have to clearly keep in mind that every additional spending results in same amount of increment in their monthly salary for western region, southern region and the northeast or north central region. Since the D1 is significant, that means alpha plus beta 1, if you see from the diagram, alpha plus beta 1, this is significantly lower than the west. So, the gap between west and northeast or north central is significantly different, but southern region is not significantly lower. So, that means this difference is not significant, this difference basically, the difference is insignificant. But this difference is significant. Okay. Difference between northwest and northeast or north central, that is significant difference. Okay. So, once the value of alpha is given, you can easily calculate the mean salary of this, okay, given a specific value of public spending, Okay. This is how you have to interpret the coefficients. So, what we have learned so far, how to estimate the model, what is the interpretation of the coefficient. Interpretation of the coefficient, I repeat, if it is ANOVA model, then the intercept will directly tell you the average value of the dependent variable, which is salary here. If it is ANCOVA model, that will only tell you the intercept. For example, here I cannot say that alpha is basically mean salary of the western region, because I have one more covariate which is x1i. So, you have to specifically put one value for x1i to get the mean salary of the western region. Similarly, for southern region and northeast region. So, d1i and d2i in this context, they indicate the difference in the mean salary. For every additional unit of spending, what is the difference in mean salary between the western category, which is the base category, with the other two categories. All right. So, now what you have to do, you just read your textbook they have nicely explained this particular example. For your convenience, for your understanding, I have taken the same example and I have explained how to interpret the coefficient. I have also give the demonstration how to estimate the model using data. So, once I give you the data set, you also can easily estimate the models and interpret. You first try to interpret of your own and then you see whether your interpretation is matching with what is given in the textbook. With this, we are closing our discussion today, and in next day tomorrow we will do, we will take another example and we will see how to estimate that particular model and interpret the coefficients. All right. So, we are closing our discussion with this today. Thank you very much.